It is a great delight to be with you, students. Recall in our last class, I taught you the topic indices. In this class, I will be teaching you exponential equations. Exponential equations are equations in which the variables occur as exponents. Join me as we take a look at this very interesting area in mathematics. I'll see you. Like I said, exponential equations are equations in which the variables occur as exponents. Example, 4 raised to power 2n minus 1 equal to 64. It is an exponential equation because you can see that the variable n occurs as an exponent. So in this class, I'll be taking examples involving exponential equations. The first one is simplify 3 raised to power 3x plus 5 being equals to 9 raised to power x plus 3. So we are asked to simplify this expression. To simplify this expression, you make the basis on both sides of the equality sign to be the same. So 9 raised to power x plus 3 will become 3 raised to power 2 bracket x plus 3. And so when you open up the brackets on the right hand side of the equation, you will be having 2x plus 6. So the expression will become 3 raised to power 3x plus 5 being equal to 3 raised to power 2x plus 6. The next thing we do, since the bases are the same, is to equate the powers on both sides of the equality sign. And so when you equate the powers, the bases will cancel out themselves, leaving you with 3x plus 5 being equal to 2x plus 6. When you collect like terms, you will be having 3x minus 2 being equal to 6 minus 5. Of course, we know that 3x minus 2 is equal to x, while 6 minus 5 is equal to 1. So the final answer will be x equal to 1. Let's take another question. And so you are to solve the equation 3 raised to power x equal to 9 raised to power half times 27 raised to power 2. The first thing you do is to make the bases to be the same. And so 9 raised to power half will become 9 raised to power 2 bracket 1 over 2, while 27, which is 3 raised to power 3, will become 3 raised to power 3 bracket 2. So we then apply the laws of indices to the right hand side of the equation. So but before we do that, 2 bracket half is the same thing as 2 raised to power 1. Then y 3 bracket 2 is the same thing as 3 raised to power 6. So you will be having 3 raised to power x being equal to 3 raised to power 1 times 3 raised to power 6. Applying the laws of indices to the right hand side of the equation, you are going to have 3 raised to power 1 plus 6. So the next thing you do is to equate the powers. So when you equate the powers, you'll be having x being equal to 1 plus 6. So finally, x will be equal to 7. So let's take another example. This time around, it involves fractional basis. And so solve the equation 5 over 6 raised to power half equal to 6 over 5 raised to power x minus 1. So to simplify an expression like this, of course, you have to make the bases to be the same. To make the bases the same, you swap the right hand side of the equation. 6 over 5 will become 5 over 6. When you swap the numerator with the denominator, then you introduce a minus sign in the power. So you will be having 5 over 6 raised to power 1 over 2 being equal to 5 over 6 raised to power minus bracket x minus 1. When you open up the powers in the right hand side of the expression, you are going to have the minus sign multiplying through the content inside the bracket. So you will be having minus times x, which is minus x, and minus times minus 1, which will give you plus 1. Equating the powers, you are going to have the bases cancelling out themselves, leaving you with 1 over 2 being equal to minus x plus 1. And then the next thing you do is to collect like terms. So when you collect like terms, you'll be having x being equal to 1 minus half. And 1 minus half is equal to half. So that will be the final answer, x being equal to half. Sometimes exponential equations eventually turn into quadratic equations. This is the last example we'll be taking for this class. And so you are to solve the equation 2 raised to power 2x plus 1 minus 5 bracket 2 raised to power x plus 2 being equal to 0. So to solve this expression, or to simplify this expression, we'll first of all try to bring 2 raised to power x wherever it may be found in this equation. And so you have 2 raised to power 2x plus 1. From the laws of indices, it is equal to 2 raised to power 2x times 2 raised to power 1 using the law of multiplication. And so you have 2 raised to power 2x plus 1 being equal to 2 raised to power 2x times 2 raised to power 1 minus 5 bracket 2 raised to power x plus 2 being equal to 0. You can as well separate 2 and x with the bracket sign. So it will become 2 raised to power x bracket squared times 2, because 2 raised to power 1 is the same thing as 2, minus 5 brackets 2 raised to power x plus 2 being equal to 0. Having separated 2 raised to power x out wherever it is found in the equation, you will now use another algebra to represent 2 raised to power x to make the expression simpler. So wherever you find 2 raised to power x in the expression, you replace it with k, leaving you with the expression k squared times 2 minus 5 brackets k plus 2. And so you can see that it will turn into a quadratic equation, 2k squared minus 5k plus 2 being equal to 0. The next thing we'll do is to factorize this quadratic equation. To factorize a quadratic equation, you multiply the first term by the last term of the expression. And so you have 2k squared times plus 2, giving you plus 4k squared. Having multiplied the first term with the last term, you look for two factors or two numbers which you will multiply. You have plus 4k squared, and by the time you add it together, you have minus 5k. And so those two factors are minus 4k and minus k. You substitute those two factors into the middle of the expression, giving you 2k squared minus 4k minus k plus 2. The next thing you do is to factorize the expression by dividing through with the highest common factor. When you group this expression into 2, the highest common factor for 2k squared and minus 4k is 2k. And so you divide through by 2k. 2k squared divided by 2k will leave you with k inside the bracket, while minus 4k divided by 2k will leave you with minus 2. On the other side, minus 1 is common to both of the terms. So you have minus k being divided by minus 1, leaving you with k, and plus 2 divided by minus 1, leaving you with minus 2. You collect what is outside the bracket and group it into 1, leaving you, which is 2k minus 1, and then you take one of the expression inside the bracket, which is k minus 2. And so when you do that, you are going to equate both terms inside the bracket to 0. When you equate it to 0 and you make k the sort of formula, you will be having k being equal to half, or k will be equal to 2. The next thing you do is that, remember that we are looking for x, the value of x, not k. You do recall that we originally said that 2 raised to power x is equal to k. And so when we take one of the solutions of k, which is half, we'll substitute that into the expression 2 raised to power x being equal to k. So you are going to be having 2 raised to power x being equal to half. And then the next thing you do is to make the base of the expression the same. To make the base of the expression the same, we know that half is the same thing as 2 raised to power minus 1. So the expression will become 2 raised to power x being equal to 2 raised to power minus 1. Since the bases are the same, you equate the powers. When you equate the powers, you are going to be having x being equal to minus 1 as the first solution of x. The next thing you do is to take the second solution for k and also substitute it into the expression 2 raised to power x being equal to k. So when you substitute 2, you are going to be having 2 raised to power x being equal to 2. Of course, we know that 2 raised to power 2 itself is the same thing as 2 raised to power 1, because whenever you have any algebra, any number written is the same thing as that number raised to power 1. So you'll be having 2 raised to power x being equal to 2 raised to power 1. Again, because the bases are the same, you equate the powers. When you equate the powers, you'll be having 2x being equal to 1. Therefore, the solution of the exponential equation given will be x equal to 1 or minus 1. I hope you had a nice time watching this video. If you have any comments or suggestion, please drop it in the questions and notes section of this page. Also remember to attempt your quizzes and assignments, as they will form part of your assessment this term. I'll see you next time. Bye bye.